Hello friends, this is Road to IIT and today we are going to solve some past year JEE problems. Okay, so as the JEE exam is very near, so we are not going to start any new chapter. We are just solving a past year good JEE problems. Okay, so let's get started. This is from JEE Advanced 2015. See how the questions is formed and how we are going to solve this. Okay, this is most important thing. Here, if alpha is equals to integration 0 to 1 e raised to 9x plus 3 tan square x into 12 plus 9x square upon 1 plus x square dx, where tan inverse takes only principal values, then the value of log mod 1 plus alpha with the base e minus 3 pi by 4 is. Okay, we have to find out this value, and for that we have to find out the value of 1 plus alpha, and for that we have to find out the value of alpha, and alpha can be evaluated by this integration. Okay, so what we have to do here, we have e raised to 9x plus 3 and tan square x. The first idea, so see how we start to think that we have to do this step. First of all, I see this 9x plus 3 tan square x. So what I do, I just take an assumption this equals to t. This is my integration. Alpha is equals to 0 to 1 e to the power 9x plus t tan square x 12 plus 9x square upon 1 plus x square dx. I take an assumption 9x plus 3 tan square x is equals to t. That means 9 plus 3 upon 1 plus x square dx is equals to dt. So it becomes 9 plus 9x square plus 3. That means 12 plus 9x square upon 1 plus x square dx is equals to dt. That means this whole term comes as a dt. Okay, so it becomes e raised to t dt, but we have to change the limit. Here x is equals to 0, x is equals to 0, x is equals to 0, that means t is equals to 0. So the lower limit is same. Now x is equals to 1. So if we put 1 here, then 9 plus 3 into tan inverse of 1, that is pi by 4. So 9 plus 3 pi by 4, that's upper limit. Okay, easy to understand. Then e raised to t dt is here. Okay, now integration of e raised to t is e raised to t, upper limit minus lower limit. That means e raised to 9 plus 3 pi by 4 minus e raised to 0, that is 1. So e raised to 9 plus 3 pi by 4 minus 1. This is the value of alpha. Now take this one at this left hand side, then alpha plus 1 becomes e raised to 9 plus 3 pi by 4. Alpha plus 1 becomes e raised to 9 plus 3 pi by 4. Now we have to find out the value of log mod 1 plus alpha with the base e. That means log of this, log mod of this, and that becomes 9 plus 3 pi by 4. Minus we have 3 pi by 4 here. 3 pi by 4 and 3 pi by 4 gets cancelled out and we left with 9. See, it's a simple but still easy sum asked in JEE Advanced. So the level is also tough. So the right answer option is 9. 9 is my correct option. Okay, let's see one more. This is also a good question from the integration chapter. Let f of x is equals to 7 tan x raised to 8 plus 7 tan x raised to 6 minus 3 tan x raised to 4 minus 3 tan square x for all x belongs to open interval minus pi by 2 to pi by 2. Then the correct expression is, see, this is a multiple choice question. So more than one answer can be correct. Now, if we are looking at the option, you can see integration of 0 to pi by 4 x f of x dx in this two option, and 0 to pi by 4 f of x dx in this two option. So you can easily understand that you have to find out the value of 0 to pi by 4 x f of x dx and 0 to pi by 4 f of x dx. So let's do that. Now, what is f of x? First of all, f of x is given 7 tan x raised to 8 plus 7 tan x raised to 6. Now from this two term, let's say 7 tan x raised to 6 common. So we left with 1 plus tan square x, that is sec square x. So 7 tan x raised to 6 into sec square x. Similarly, from this two terms, minus 3 tan square x gets common, and we left with 1 plus tan square x, that is sec square x. So this equation can be written as 7 tan x raised to 6 into sec square x minus 3 tan x raised to tan square x into sec square x. Now, in this two terms, sec square x gets common. So we have 7 10x raised to 6 minus 3 tan square x into sec square x dx. Okay, so this is my f of x. Now we have to find out integration 0 to pi 4 f of x dx. So what we have here, 7 10x raised to 6 minus 3 tan square x into sec square x dx. Now this is the differentiation, this is the function. You can see this is a now easy task. Let 10x is equals to 6 or 10x is equals to t, so the sec square x dx becomes dt, or you can easily integrate directly because the function 10x is here and sec square x is here. So this power is increased, 6 plus 1 upon 6 plus 1, that is 7, 7 gets cancelled out, so we left with 10x raised to 7 minus 10 cube x. Similarly here, 10 to the power 2 plus 1 upon 2 plus 1, 3 gets cancelled out. Now upper limit minus lower limit. First of all, upper limit, so 1 minus 1, that is 0, minus lower limit, 0 minus 0, that is again 0, so we have 0 here. So first option for integration 0 to pi by 4 f of x dx, 0, so option B is also correct. So first my option B is correct. Now we have to find out 0 to pi by 4 x f of x dx. So for that, multiply our answer, our f of x, that is 7 10 x raised to 6 minus 3 tan square x dx into sec square x with x. Now this whole sec square x into this 7 10 x raised to 6 minus tan square x as a 1, that is u, you can say that, and this is as a v, or here we take the x as a u and this as a v because it's easy to integrate. Okay, so x as a constant, u integration v ds. This function integration is 10x raised to 7 minus 10 cube x, as we saw again in the previous slide, from 0 to pi 4 minus d by dx of x, that is 1. We are just applying the uv dx rule here. Okay, and integration of this 10x raised to 7 minus 10 cube x into 1 dx. Now we have to again integrate this. Integration of uv dx formula is known to us. Now for this particular integration, what we are going to do, let's 10 cube x common, so we left with 10 raised to 4x minus 1, and that can be written as 10 square x minus 1, 10 square x plus 1, and then 1 minus 10 square x is here, 1 plus 10 square x becomes sec square x. Okay, easy. Now as we do in here, and if this pi by 4 is applied, this integration becomes 0 as we saw in the previous slide. Okay, this is very easy to understand. Then the 10 cube x, 1 minus 10 raised to 4x, as I told you, then 1 minus 10 square x is here, 1 plus 10 square x is sec square x. Okay, and now we have 10x here, let's 10x is equals to t and sec square x dx becomes dt, so directly we can integrate this and this becomes 10 raised to cube, its integration, that means 10 raised to 4x by 4, 10 cube into 10 square, that is 10 raised to 5, its integration 10 raised to 6x by 6 from 0 to pi by 4. Okay, this whole part becomes 0 as we saw in the previous slide, and we have to find out just this value. Now let's put pi by 4 here, so 1 by 4 minus 1 by 6 minus 0 0, it's 0, so 1 by 4 minus 1 by 6 is 1 by 12, a very good sum. Okay, so this is my right option, so option number A is also right. So A and B both are the right. This is a multiple choice question asked in JEE 2015. Let's see one more. This is also a good question from quadratic equation. See what we have here. Let S be the set of all non-zero real numbers alpha, that the quadratic equation alpha x square minus x plus alpha is equal to 0 has two distinct roots x1 and x2 satisfying the inequality mod x1 minus x2 is less than 1. Which of the following interval is the subset of S? Now please understand this question. S be the set of numbers of alpha, and we have to find out the subset of S. That means we have to find out the values of alpha which can satisfy this equation. Okay, because S is S containing the value of alpha, and we have to find out the subset of S. That means we have to find out the values of alpha which satisfy this and this equation. Now first of all, this equation has two distinct real roots. Now for the two distinct real roots condition, topic lecture, important theory, alpha x square minus x plus alpha is equal to 0, two distinct and real roots, that means discriminant greater than 0. b square minus 4ac, 1 minus 4 into alpha greater than 0. That means 1 by 4 minus alpha square greater than 0. That means, just reverse this, alpha square minus 1 by 4 less than 0. That means minus 1 by 2 less than alpha less than 1 by 2. We come to this conclusion by just equation number 1. Okay. Now we have one more equation, that is modulus of x1 minus x2 less than 1. And that particularly means that modulus of x1 minus x2 can be written as square root of x1 plus x2 whole square minus 4x1 x2. This we saw in the topic lecture and the previously solved J-double equation also. Why we do that? Because we have the two formula only, that's the summation of the roots and multiplication of the roots. So whenever the subtraction is given, we have to use this formula, because we have the values of summation and the multiplication. Summation is minus b by a. So from this equation, minus b by a, that means minus into minus 1 upon alpha, that means 1 by alpha. So summation becomes 1 by alpha. And then multiplication is c by a, that means alpha upon alpha, so it's 1. Summation is 1. So mod of x1 minus x2 is equals to square root of x1 plus x2 whole square minus 4x1 x2. This is 1 by alpha whole square, that means 1 by alpha square minus 4 into 1, that is 4 itself. As we know that this is given in the question, so this whole thing is less than 1 as per the question. I just go here. Now squaring both the sides, that means 1 by alpha square minus 4 less than 1. That means 1 by alpha square less than 5. That means 1 by 5 less than alpha square. That means alpha is less than minus 1 by root 5, or alpha is greater than 1 by root 5 as the basic inequality. So this is my first, this is my second value of alpha, and the first value is here minus 1 by 2, alpha less than 1 by 2. Now we have to take the common interval from these two. This is equation number 1 and this is equation number 2. And if we both taken out the common part, then the answer becomes alpha belongs to minus 1 by 2 to minus 1 by root 5 union 1 by root 2, 1 by root 5 to 1 by 2. Okay, you can see in the number line also. This is a very easy thing to understand. So here also two answer option is right, that is A and D. A minus 1 by 2 to minus 1 by root 5, 1 by root 5 to 1 by 2. Okay, see now you have to understand how to evaluate the sum. Sometimes it happens in the exam that we know the formula but we don't know how to apply it. That's why I'm going to solve the previously asked J-double-E questions, real J-double-E questions. So this is all about today's video. I'm not going to post any new thing up to J-double-E mains 2017. I'm just going to post a previously asked J-double-E question. So keep watching. If you have any doubt, ask me in comments. Thank you for watching this video, and if you like this video, don't forget to share it and hit that subscribe button. Thank you.